Okay, very good, very good, very good. Good day once again. I believe we are all doing well today too. Good. So today too, it's another great day where I will still continue leading you through the branch of mathematics, which is termed as Surds. So over here we are still on Surds, but today we are going to dive into the area of search, which is specifically rationalization of what search. Rationalization of search. So I want you to stay tuned so that today's lesson too will be of a great one for you. We believe that and we hope that at the end of the day you'll be able to understand whatever thing that we are going to talk about here. Please stay tuned and do not forget that you subscribe to this channel and you stay tuned as well. Make sure you share this channel or this link to your friends so that they will also see the benefits that you are enjoying here. Very good. So let's start with the process. So I said that today we are going to look at rationalization of search. In my previous videos, I explained to you what we meant by search. So I don't want to waste my time on that explaining what we meant by search. So we continue with the rationalization. Now over here we have some question samples on the board, and with this we are going to look at how to tackle each of the questions one after the other. So look at question number one. I have one on root 2, one on root 2. You realize that this is a fraction, but a fraction involving was set. Now this fraction has a numerator being a monomial, that is one thing, and the denominator being a monomial, that is one thing. So with problem like this, we have a way in going about it. In the same manner, if you go through with question number 2, yes, this is also a fraction. Now you can clearly see that this fraction has a numerator which is 3, which is a monomial, and the denominator which is 2 minus root 2. That is a binomial. That is a complex what? Set or a compound set. So it has two terms. That is binomial. So that one too has a way in going about it. And we come to question number 3. That is a fraction involving set. The numerator being 6 minus 2 root 3. It is being a binomial. In the same manner, looking at the denominator, that is a monomial. So this question too has a way in going about it. In the same manner, if we go through with the question number 4, which is the last question that when we are done going through all of them, you will be blessed today. So looking at the numerator, we have 1 plus root 6 being a binomial. In the same manner, if you look at the denominator, which is 1 minus root 6, also being a binomial, and this one too has a way in going about it. So let's quickly dive into how to solve question number 1, then we go through with the rest of the questions. Very good. So we are started. Rather my solution, then come closer, then we all learn together. Okay, so question number 1. Now, solving question number 1, we are solving it through rationalization. Are you with me? So the idea of rationalization states that anytime that you have a fraction with which the denominator has a side in there, the fraction becomes what? Unstable. So with that, you have to do something to it so that the denominator bearing the fraction, sorry, the denominator bearing the side will just go away. The side with respect to the denominator will go away. So this we are going to do something to the denominator so that the side will go away. Now, because the denominator here is root 2 being one thing, which is a simple set or a monomial, what we are going to do is we multiply both the numerator and the denominator by the set, which is the root 2. So we are going to multiply the numerator, which is root 2, over root 2. So for problems like this is how we go about it. If the denominator is a simple set, that is a monomial, you just check the denominator, use to multiply both the numerator and the denominator, likewise what we are having here. So mathematically, this can be expressed as 1 multiplying root of 2, which is over root of 2 multiplying root of what? 2. I believe you are following. Very good. So we continue with the process. So this is what we are having here. So in the next manner, we dive into how to multiply this. Now in multiplying a whole number by a thread, we told you that a whole number cannot multiply a number under the root sign. But I have it in mind that this thread has a whole number in front of it. So we are going to dive into it, looking at how to multiply that. Now in multiplying, we don't multiply the 1 and the 2 here, no. There is a whole number in front of the set, which is 1. And we don't normally write this whole number. The same man when we can there's a whole number 1 here and a whole number 1 over there. So we are going to multiply 1 times 1, which will give us a certain answer. So 1 times 1, we are going to get 1. I get me? Then the root 2 will come into play. All over. So we are to multiply 1 times 1. What we are going to get what? 1. And then we are going to get what? I believe we are following. Very good. So this is what we are going to get. So following the process, we are having 1 root of 2 all over. Now you multiply that. Now you are getting 1 root of what? 4. Because over here, when we multiply 2 times 2, we are going to get what? 4. And 4, we are getting 1 root 2 over 1 root 4. Have it in mind that I told you earlier that the essence of rationalization is to get rid of the third which is found within the denominator region. So here we are doing something to make sure that this root 2 goes away. I get it? Yes. This root 2 goes away, and this is what we are doing, and it is called rationalization. Right? So here we all know that mathematically we have 1 root 2, where 1 root 2 is the same as what? Root 2. I get it? It's like you have 1x. 1x is the same as x. So here we don't waste time writing 1x or whatever. I believe it is clear. Very good. In the same manner, if I come down here, so this one is the process, and I am now here. Okay, so when we come down here, you realize that this can also be written as root of 4, because well, I told you that 1x is the same as what? X. So here if I have 1 root 4 is the same as what? Root 4. Are you okay? Very good. So we continue with life. So that is why over here I've written root 4 as you can see over there. So in the same manner we continue with process. Okay, so when we continue with that, we are having root of 2 all over. Now root 4, we all know that root 4 bears the answer to this 2. I believe it is clear. Very good. So we all know that root 4 is the same as 2. Let's see why we are saying that root 4 is 2. Have it in mind that mathematically, root 4 can be rewritten as root of 2 over 2. And this can be rewritten as 2 over 2 or power half. So this 2 cancels that, and we are going to get what? 2 power what? 1. I believe it is clear. Very good. So that's what we are getting. That's why 2 power 1 is the same as 2. That's why we said that here root 4 is the same as 2. So we are done, and then our answer then becomes root of 2 over 2. This then becomes our answer, because we are done getting rid of the root symbol on the denominator. Now initially it was root 2, 1 over root 2, and now you realize that the denominator now has no radical sign. So we are done rationalizing it. Have it in mind that I said rationalization simply means that we are getting rid of the root symbol that is affecting the denominator. So here we are done getting rid of the root symbol, and this becomes our answer. I believe it is clear. Very good. So quickly, let's dive into question number 2. So if you see question number 1, this one has a simple set, that is a monomial. That is why we went through with it like this. So its approach is something like this. And now, question number two has two terms. So that one too has a way in going about it. Are you with me? Very good. Now, if you look at question number one and question number two, you realize that looking at the denominators, okay, the question number one has a denominator which is 1/10. Question number three also has a denominator which is 1/10. So I want us to solve question number three so that you will not get confused. Are you getting me? How to solve question number one is similar to question number three because this one has a single or a simple set as the denominator, and this one too has a simple set. So let's also question number three. Then after we come in, we dive into the situation whereby the denominator of the fraction is a binomial and a binomial. Okay, very good. So let's see what is happening here. So question number three, I have 6 minus 2 root of 3 all over root of 3. Are we good? Very good. So here we said that rationalization simply means you are getting rid of the radical sign that is affecting the denominator. And we cannot just stand up and say that the root sign should go away. No, there is a rule, there is a procedure that we have to go through. And this procedure is what we need to understand. Now, because this one is a monomial, that is one term, we just straight away multiply both the numerator and the denominator by the set that we have over there. So the numerator and the denominator. So this whole thing by root of 3 all over root of 3. So that's the radical sign here will go away. Are you getting me? Very good. So let's continue with life. So now I can rewrite this whole thing as root of 3 multiplying what I have here, 6 minus 2 root of 3 in the bracket all over. I have root of 3 multiplying root of 3. I believe the bracket that I've introduced over there, you get it, because root 3 is what I have here. So it is multiplying everything, and here to root 3 is multiplying. Likewise, I have root 3 multiplying this, it is the same as what I have here. And here too, it is multiplying the same as what I have here. So here, as we know how to multiply a monomial by a binomial, so this one will take charge of this will take charge of that, and we continue with the process. So let's continue quickly so that we will not waste my time. So here, continuation, I have root of 3 in a bracket 6, that is multiplying negative root of 3. It is the sign here that has come. So 2 root of 3 all over this root 3 multiplying that. So I have root of 3 multiplying root of 3. I believe you are following. So this is what we are getting. So here we multiply it one after the other. Then after we continue with life. Very good. So let's continue with the process. So here I have, you realize that the 6 here is a whole number, and this is a radical or a surd. So we cannot multiply the 6 by the 3. Look, it's a whole number. So this 6 needs to multiply the whole number in front of the radical sign, which is 1. And yet you have a whole number 1 here. I believe you are following. Very good. So the whole number will multiply this whole number over here, where I'm going to multiply the 6 times 1, which is giving me 6 over here. So I'm going to get 6 root of 3 minus, let me write it 12. So I'll get 6 root of 3 here. Very good. So here too, there is a whole number here and a whole number. So the whole number 2 will multiply the whole number 1. So 2 times 1, well, I'm going to get over 2. So I now have it in mind that it is a negative number multiplying positive. And we all know that mathematically, Very good. So we all know that mathematically, when negative multiply positive, we are going to get negative. So we have negative 2 root of, and now this 3 will multiply what we have there. So we have 3 multiplying 3. I get it mean. All over this one also we have root of 3 multiplying root of 3. And this is what we are getting. So continuing with the process, we have this 6 root of 3, then minus 2 root of, now 3 times 3 we are getting what, 9, all over, and 3 by 3 we are getting what, 9. 3 times 3 is not 6, it is what, 9. So this is what we are getting. And now continuing with the process, we all know that root 9 is what, 3. You know that, very good. So here I have 6 root of 3 minus 2 in a bracket. We know that root 9 is the same as 3. I believe it is good. Very good. So root 9 is 3 all over, and root 9 is what? 3. We know that root 9 is 3. So proving it over here, I believe you know why we said root 9 is 3. I explained it in the previous section. So please have it in mind that root 9 is 3. Very good. Let me explain it here. Why we are saying that root 9 is 3. Have it in mind that mathematically, when we have root 9, is the same as, it is the same as we have an root of 3 all squared, because 3 squared is the same as 9. I would mean, very good. And continuing with in here, I have 3 squared over half. And this 2 will cancel that, leaving behind 3. Or mathematically, this power 2 will cancel that, leaving behind 3. That's why here we are getting 3 over there. Please, I would be very good. So here, now have it in mind that this negative 2 is in product terms with what, the root 9. So I told you earlier that mathematically, if I have 2x is the same as 2 multiplying x. I get it. So 2x is the same as 2 multiplying x. In the same manner, if I have 2 root of 9 is the same as this, it is still in product terms. So please don't confuse yourself. So that's why I've written it here like that. So if I should continue, I have 6 root of 3 minus, if I multiply now, because 3 here is now a whole number, I can multiply this 2 by the 3, where I'm going to get negative 6 all over 3. I get it? Yes. So this is what I am getting. So for now, for your level, we can end here as your final answer. But if you move on mathematically, or if you are abreast with some mathematical terms, we can use some kind of factorization to do something here. I get it? There's a common member 6 here, there's a common member 6 here, so we can continue with the process, then everything will be fine. So continue with the process here. If I should clean this portion and continue it here, I have 6 root of 3 minus 6 all over 3. I'm saying that for your level, you can leave here as your final answer. But if you continue, if you understand factorization, you can factorize the common thing that we have out there. So let me clean here a bit. Then after I'll continue with the process. So let's continue with life. So I have, you see there's a common thing here, there's a common thing there. That it is what, a binomial. It is like you are having 6x minus 6. Now factorizing, you can realize that 6 will come out leaving behind x minus 1. I believe you are getting this. So in the same manner, this 6x is similar to 6 root 3 minus what? 6. Are you okay? Very good. So that one too I can easily factorize. So factorizing that, I'm going to get 6 in a bracket root of 3 minus 1. Okay, all over 3. And now you can see that this 6 can get rid of. That's how many times? 2 times. Okay. Leaving behind my 2 in a bracket to root of 3 minus 1. Okay, so this then becomes our answer. So 2 bracket open, what do we have over there? You can leave your answer like that. Or I told you you can leave your answer like this. But if you want to continue with the process, you can continue by factorizing over here. This is out as the common term, then you cancel out. I get it. Very good. Now don't try canceling this story by this. No, please don't try doing that. Don't never try canceling the 6 here by no, because the numerator over there is a binomial. So if you try to do that canceling the 3 by the 6 here, you may get it wrong. But you can only do it by trying to split them. You can do it only when you try to split. I get it. Very good. So let's continue with life. Now I want to claim this section. Then after I show you what I mean, this can be our final answer. This can also be our final answer. In an examination, if you leave this as your final answer, you'll be marked correct, and this too you'll be marked correct. I get it. Okay. Now maybe you did not understand the factorization that I did here. So I want to use an alternative means with which you can arrive at this without using the factorization. So be in line with me and let's continue here. So I am saying that we had 6 root of 3 minus 6 all over 3. I am saying that you can decide yes, this is what I was saying. You can decide not to do the factorization. That is, if you are not abreast with the factorization, you can decide to split it up. Are you okay? So here, splitting everything, I have it in mind that here, because I have 2 terms here. Now this whole thing, which is 6 root 3, is 1 term on each one. So that one, splitting it up, it will be over 3 minus my 6 over 3. So with that, you can split it up to get something like this. And this is mathematically accepted. It is mathematically what? Accurate. I get it. Very good. So without a factorization, you can use this approach by splitting. Now if you split it up, you realize that you are getting a single fraction here and a single fraction. So over here, you can decide to cancel. So here, because 3 is a whole number, I can use the 3 whole numbers to cancel the 6 as a whole number as 2. Then here, because 2 is a whole number, I can use the 3 to cancel this whole number, but not this. Okay, this is a whole number and this is a whole number. This is not a whole number. So I can cancel it this manner. Very good. So here, it is leaving 2 root of 3, then minus 1, 2. You realize that when you expand this, you see we have common terms here. So I still have minus 1 as my final answer. Okay? Yes. So when you expand this, you are going to get this. So this is the same as what we have here. That's why I want to tell you that if you factorize 2 out, you realize that 2 times this, you are going to get 2 root 3. 2 times negative 1, you're going to get this. So you realize that this is an alternative way in going about it. So either you choose the factorization approach or you choose this splitting approach and everything will be fine. Very good. So now it's left with that question 2 and question what 4. So problems which involves binomial denominators, it has a way in going about it. I get me. So for now, I want you to understand the fact that when solving fractions involving surd through rationalization, always check the denominator. If the denominator is a simple set or containing a set that is what a monomial, you have a way in going about it. That one, you just straightforward multiply both the numerator and the denominator by the simple set. I get me. But in a case whereby the denominator is not a simple set but a compound set, it has a way in going about it. So for now, that I don't want you to get confused. I want you to feel okay with this. Then I will do another video on this one. So meet me in the next video for further details or for further explanation on problems which involves binomial denominators. Thank you very much for staying tuned with us. Have a wonderful day, and please do not forget to like, subscribe, and you hit the notification bell so that you'll be the first person to witness our video anytime that we come on board with any video. Also, do not forget that you share it with your colleagues out there who are also facing problems in mathematics, specifically under share. So please try and share it with them so that they will also be blessed as you are blessed today. Have a wonderful day. Bye bye.